let's get started today. Today we're going to be talking about functions once again. And the subject of this is going to be function notation. So we'll get into that in just a minute. But first of all, let's look at our bell work. So the first question is a car traveling at a rate of 65 miles per hour brakes at a steady rate to a stop. The function is given by this equation. And that talks about how fast the speed is of the car is after so many seconds of stopping at this rate. Okay, now is the domain of this function discrete or continuous? And I would maintain that it is continuous because you start out at 65 miles an hour and then you just slow down until you're down to 0. But you pass every one of those speeds in between as you continue to brake and slow down. So those are not values that you can count. Okay, next, write a linear function that relates x to y for the graph in this one. So we've done that a couple of times, but in this case we know that b equals -1. Slope is up 2 over 2. So m equals 2 over 2. So our equation is y equals 2 over 2, which is just 1x minus 1. Or if you want to, you can drop that 1 in front of the x and just say x minus 1. Okay, the next one. In each relation, is each relation a function? So if you look at these particular values, you notice that this is the x values, these are the y values. And so as you look at the x's, 0 shows up twice, giving us 2 different y values. So this would definitely be not a function. This next one, if you do a vertical line here, you would notice that you would actually hit this line a couple of times. So because we hit twice with any vertical line, then this would not be a function as well. So that's how the vertical line test can work in this case. All right, so today we're looking at some different functions. We got y equals 7x plus 2, or y equals negative 1/3 x, y equals negative 1x plus 6. So function notation is just another way of writing the same thing, but because this is a function of x, we sometimes like to write it like this. F for function with x in parentheses equals 4x minus 8. It's the same thing as y equals 4x minus 8 as well. It's just a little bit of a different notation. The reason why we do this is so that we can write functions for all kinds of different applications, and because we sometimes use different variables. So we might not use always a function of y, or we might have several equations that have y equals, and the rest of the function might be different. So this function notation just gives us some more options for how to use it and how to write it, and especially when it comes to putting it in a computer program or something to help us calculate a lot of data. Okay, and then another way that this helps us is if we have it in function notation, we can say, all right, what would be the value of this function for x if we put the number 3 in for x? So that means we go to the actual rest of the function and say, okay, what is 3 plus 9? Because we put in 3 for the x. And that just equals 12. Or if we had put in y there first, then y would equal 12 if we had put 3 in for x. We might remember doing these little tables of values. What would happen if you put in 3? 3 plus 9 is 12. So kind of another way of writing the same information. Okay, so here's a couple of functions. Let's put in the number -3 into the function and see what we get. So -3 minus 5, that would just give us -8. The next one, what if we put 2 in for our function? Then we would end up with 2 minus 5, which would equal -3. So those are two different values if we put in these inputs into this function. What about this function? This is a little more complicated, but we're going to put in the number -4, so 3 times -4, and since that's a -4, I'm going to put parentheses around it as I square it, minus 5 times -4. So I'm being careful how I put the data in. So -4 squared is 16. 3 times 16, this whole first part is equal to 48. And then -5 times -4 is positive 20. So that entire thing equals 68. What about f of -1? So then we would have 3 times -1 squared minus 5 times -1. So 3 times -1, well, -1 squared is just 1. 3 times 1 is 3. And then -5 times -1 is plus 5. So this would equal 8. So as you do these, you got to watch your signs, the positive versus negative. What are the rules for multiplying? And be kind of careful, but they're really easy to do if you'll pay attention. Okay, well, here's one where instead of using f of x, we're using g of x, because we can use different letters, because g might stand for something else, growth or something of that nature. So we've got 2 times 0 plus 1. So 2 times 0 is 0, 0 plus 1 is 1. How about 2 times -1? This tells us to input 1 into our function, and then add 1. So 2 times -1 is -2, and -2 plus 1 equals -1. All right, I like it. So given the graph of the function f of x, find the following. So I want to know if the function if I put in -5 in my function, what would the y value be? Well, to do this is kind of a fun little thing. We know this is not linear function, so in order to find our y value, we got to do a little watching the graph as we plot this. So let's go to -5 on the x-axis, and then go up till we hit the line. And we notice that lines up with, on the y-axis, positive 5. So that would be 5. At -3, we would go up from x equals -3 till we hit the top of that graph. And then we turn the corner and go to the right, and we find out that we hit number 9. Well, what about f equals 2? If we go over here to x, that would mean x is 2. We go up until we hit the line. We hit it rather quickly, and we turn and go. Hit the wrong button. We go to the left, and we notice that we just hit at 1. So if this function at the value of x equals 2 would give us a y value of 1. So the last one, what about an f function value of f of 3? So let's go over to 3, and then go up, and we hit right there, and you can kind of tell if you go to the left, that would equal a y value of 4. So there you go. There's our function values, and all we have to do is look at the graph to figure those out. So the assignment will have those kind of problems on it, and it's called Function Notation Worksheet. So we'll have a worksheet for you to work on. So good luck and thank you very much.